Okay, welcome back to the next module as part of week 7. As you know, we are covering the week 7 material right now. So from the beginning of the week 7, we looked at some of the sustainable design, how to go as an engineer, what are the things we need to take care of when we are trying to make our design more sustainable. And we also looked at, if you remember from the last module, we looked at the example from the transportation industry, how the transportation industry has taken how it works at different levels in terms of incorporating sustainable aspects in their design. We also looked at the LEED certification, which is a big thing in terms of the green buildings globally throughout the world. In Indian context also, we have the green building which is known as Griha. You can go on website and look and do Google on Griha. You will find the green building requirement as far as the Indian government is concerned, which is very similar to the LEED certification requirement. So today we will start looking at some of the principles, sustainable engineering design principles. So if you are going to do some design activities, what are the things you need to look at? So a little bit of backup in terms of some of the background, and then we'll start going into some of the newer material. So if you remember from the very beginning of the lecture, we had talked about this Brundtland report. This is how this whole concept of sustainability started. The Brundtland report was the first United Nations sponsored study done in early 1990s, which came up with the definition of this sustainability, and which we have already looked at several times throughout this course so far. Then came the Hannover Principle. Hannover Principle, their main idea was that when we talk about the human system is all these buildings, and we are talking about the infrastructure or any activities that you do, and you come up with this beautiful buildings, beautiful highways, roads, bridges, and all that. They must design to be coexisting with the natural system. So that was the Hannover Principle, which came after Brundtland report, which is kind of, if you think about it, it's kind of in the continuation of what was there in the Brundtland report in terms of the sustainability principle, that we should be able to enjoy the natural resources of today without compromising the future generations' ability to enjoy the same. So along the similar lines, the Hannover Principle says whatever construction you do, whatever infrastructure you develop, don't disturb the nature. So you do it while taking the nature along with it, which is sometimes very difficult to do it. So just recently, as part of this new budget, which was just happened just few days back, and there is a proposal to make train lines between I would say Tejpur to Tawang in Arunachal Pradesh. Tejpur is in Assam, Tawang is in Arunachal Pradesh, and lots of money has been allocated to that. Recently, I happened to visit that area, so I can see things are very clear, it's a very fresh in my mind. So if you think about that, there is a lot of natural beauty there. So although we need the railway line will really be great, but because it took me 2 days to go from Tejpur to Tawang, but railway line will make a great addition. It will actually enhance the tourism potential of Arunachal Pradesh, of that particular area. But at the same time, we need to make sure that happens not compromising the beautiful natural beauty, the natural scenic beauty that we have in that region, because we don't want to disturb that. And we have to come up with, that would be really a classic example where we should come up with a sustainable design of this railway infrastructure. Railway will be great because we are using lots of vehicles now, so vehicular pollution, and if it's an electrified or even if the diesel, because it can carry lots of people in one railway train. So ultimately, I'm pretty sure if you do a life cycle analysis of that, we will come up with that the railway will be a good addition, and that will bring down the air pollution or other pollution that is happening in the area. But at the same time, when we are building this railway track, we need to be careful that we don't do it by disturbing the natural flora, fauna, a lot of waterfalls and other things that is present in that area. So that's the concept of this Hannover Principle, that whatever you make, whatever the human system you come up with, that should coexist with the natural system. Then came this Augsburg Materials Declaration, which came in 2002. There kind of we start looking at, okay, how to, so if you think about this Hannover Principle, the human system should coexist with the natural system. So how we'll make it happen? one of the things is that, okay, you come up with environmentally benignant design, which is, what does it mean? Means that you come up with an environmental cautious design. So you make it something which is less harmful. So you make materials and manufacturing, you look at the materials and manufacturing over all stages of life cycle. You try to optimize the and exploitation of raw material and natural resource. You try to go for energy efficient production, renewable energy sources, durability, recyclability, and closed loop recycling, and all those things. That's the Augsburg Materials Declaration. Again, all these things came as part of some initiative of UN, World Bank, and other global organizations. And as you can see, gradually we are making progress towards going for more sustainable kind of based system. And some of these are they are still kind of you can say that they are still in the report. They are not part of regular practice yet. Things do take time. Think about that 2002. It's only like 15 years back. So things do take time, and industry sometimes takes a while to kind of to catch up. But things are happening in that area where we are looking at many of these aspects in terms of our industrial activity. In India, as you know, from very early 2000s, we have to have EIA to be done in any project, which will be kind of similar. And now, as I hear that LCA will be made compulsory for any of the projects in India from for after a couple of years, which is under pipeline. So then, kind of after this, after these three things, then came this Sandestein, Sandestein Sustainable Engineering Principle. So here now, say as an engineer, what are the things we need to take care of? What are the things we need to, because when we start designing, so far as we have been designing any product or services as an engineer, the focus has always been that whatever the function it has to provide, the product or process, or what like process is also a product, or any software packages or whatever you come up with. So they should be able to provide that function. That's the number one. And number two, as much as possible cost effective. So it should do the function, and it should be as cheap as possible. So those were kind of the major like a driving force behind designing of any of these products, processes, and other stuff. Now the things has to move a little bit. It's not only like doing the function and having cheaper, but at the same time it should be environmentally better, environmentally kind of cautious, taking care of the environment, and as well as the social aspect. That's how whole sustainability comes into picture. So if you look at these engineering principles in terms of coming with this sustainable engineering, so first thing was we have to look things holistically. Now when we say holistically, means don't look at things in one compartment, look at the things in big picture. So if you are trying to design a certain product, say even if you're trying to design a particular type of chair, look at the chair in terms of its raw material acquisition all the way to disposal. Not only look at, okay, raw material, this is cheaper, this manufacturing is cheaper, that's great. No, because we have to look at its use phase as well as its disposal phase. Does it have certain harmful chemicals or certain things in present which will have its impact during the use phase, whether people will get sick because of the certain things being leaching out of it? And when you dispose it, what will happen to that? When you dispose, whether it will be an environmental impact, what is the environmental footprint when this product goes into a disposal stream? So that when you look at the whole big picture from cradle to grave or cradle to cradle, that's your having a holistic approach. And use systems analysis, something like a different name for the same thing. Use a system analysis, integrate environmental impact assessment tools, look at the environmental impact for each and every process involved from the cradle to the grave, and possibly for recycling. Now then other thing is conserve and improve natural ecosystem. Again, very similar to what the earlier slide you saw in terms of the Hannover Principle. It's the same thing. In the Hannover Principle also said that you need to go along with nature. Here it says conserve and improve natural ecosystem while protecting human health and well-being. So we have to make sure we protect the natural ecosystem. Again, it kind of goes back to this like a discussion we had earlier, where we said that it's see, having a good GDP, having a good of prosperity is always great, but not at the cost of people getting sick, not at the cost of people not having access to clean drinking water, or having a lot of polluted air around it, because ultimately it's all this prosperity and GDP is for the people, and if the people cannot enjoy it, if they get sick, if they cannot enjoy that thing, what's the point of having it? So, and then use life cycle thinking in all engineering activities. So all of these, as you can see, they are kind of overlapping with each other. Each and these different principles, they are not kind of mutually exclusive principles. They are again overlap with one another, and just gives you kind of some idea about like a kind of again, if you go at look at the basic point is take care of the environment, they have be responsive towards a social cause, should provide the function, and so those, what are the things you need to do for that? So then ensure that all material energy input and output are inherently safe, so it's not safe and not harmful. So again, same thing, you can try to have safe sources of energy, material with less toxicity or no toxicity possible, minimize depletion of natural resources. So all these factors, with this I have listed each one of them because they are actually part of this Sandestein sustainable engineering principle. If you pick up any green engineering book or pollution prevention book, there will be a chapter on this different principles of sustainable engineering, and you will see that this Sandestein sustainable engineering principles are there. So it is being taken from a book which was I think I gave you as a possible reference book, which was sustainable engineering. So it's basically taken from that book, and these points were listed, so I have kind of listed it over here, but as you can see, most of these are overlapping with each other. Other point is strive to prevent waste. We don't want much waste material to be produced, so less waste. Try to and then you have to be sensitive towards the local geography, aspiration and culture. That's very, very important. See, if you come up with this solution, especially something where people, a lot of I would say people's direct interaction is involved. So if you come up with certain kind of a solution which has some sort of cultural significance, social significance, and then if you try to apply that principle, apply that solution across the board throughout the globe using the same yardstick, things may not work out very well for you. What I'm trying to say, let's take an example. Until very recently, I would say even today, many parts of our country, people don't like to have the toilet inside the house. And the reason for that, if you look at historically, what I think the reason for that was, since the toilet, if it's not kept properly, it starts smelling, or if there will be some sort of foul smell coming out. So people are not, and they will have kitchen in their houses, and then they are not happy having that foul smell in the house. So they want to build the toilet outside, and they will use it outside. Over the years, people have realized, as we are having more older people in the house, small kids, ladies in the middle of the night, if you have to go for the nature's call, it was getting difficult to go in something which is outside. It may not be safe. It may not be safe from, say, snakes and other stuff, because many places electricity is not always guaranteed, and then you may have it may be too cold, it may be rainy season. So all those things taken into consideration, gradually now people are more receptive to having the toilets built inside the house. But still today, if you go to many of the rural area, they may not like that idea. So if we come up with a solution and then we try to force that solution to the rural areas, where we force people to have the toilet built inside the house or part of the house, they may do it just because of the pressure from say government, semi-government organizations, and at the same time they may do it because they are getting some financial incentive to do it. But at the end of the day, you will see that they may not really use that. So what I'm trying to say, that we need to really understand the cultural value. We need to understand the practices of that region, and especially when you are trying to come up with some solution which could be linked to that, and then take the local population on board. If you try to just throw out the solution, just try to force the solution, of any activities in the rural areas without taking those people, local panchayat and other people on board, that what will work there, what will not work there, things will not go much longer. Then it may not be sustainable. It will not be a long-term solution. So that's always should be taken into consideration. We should try to create engineering solution beyond current or dominant technology, improve, innovate and invent. Same thing again, going back to the same discussion of the toilet. The problem with most of this toilet design, and why I'm saying too much of a toilet stuff, is because as part of the Swachh Bharat mission, we are building lots of toilets today in India, and over the last couple of years, it was being built earlier too in the Nirmal Bharat Abhiyan, or even before that, but this with the Swachh Bharat mission, lots of fanfare, lots of kind of focus, and I would say better implementation as being so that's what it's like people are trying to achieve certain targets. So in that aspect, lots of toilets are being built, but the and I will not go into the toilet design, whether it's a good design or bad design, soak pit is a good idea or bad idea, that we can leave it for some other class. But for if you think about in terms of the sustainable solution, what the worry is, these toilets are very water intensive toilets. So it requires lots of water, because it's the traditional toilets that you typically see in a household, where you have a flush and the flush uses a lot of water, it flushes the system out. But the question is, what will happen during the summer months? Today, like as by the end of this course, summer will probably start, and as if you go into the summer month, what will happen? Whether these toilets, whether they will have enough water. What has happened in previously, where the similar toilets were built, where people have found that during the summer months, because of the lack of water, people were not using the toilets anymore. And since they were not using this toilet, they were just because there was no water, they were having difficulty in getting water even for drinking and cooking purposes. So there is no who will use the water in the toilet at that particular time. So they started using open defecation. Since the toilets were not used, not flushed, it is started, and there was no water going into the toilet, because the microbial species inside, they like to have some moisture, and if over the time the moisture level goes down, the bacteria are not happy, and that actually creates problem into the anaerobic system that we have in terms of like a design of the treatment system as part of this toilet. So if you don't have the water going in, what happens is the toilet becomes non-functional, and then it sometimes it starts stinking again. So, and the people, since they start going outside, they start again even after when the rainy season, other things come, this toilet becomes like a either a secondary usage, or sometimes even converted to a storage area and other stuff. So then it doesn't become a sustainable solution. So what I'm trying to say, as the point number 8 over tries to say, that we need to come up with a engineering solution beyond current or dominant technologies. So this water intensive toilets are not going to work, especially in many parts of the country, in our country. So we need to come up with a better design. We need to come up with a design which can really work in our, so it's like a waterless toilet or whatever. We need to come up with design, and there are some designs out there. We need to really pilot it, test it out, make sure it really works, and then come out. So sometimes it's okay to rush things. Sorry, I will say it's okay to do things fast, but we should not rush things too much. So you need to look at whether this technology is really going to work. I remember somebody mentioning that in one of the meeting, which I really liked, but it's in Hindi. Those of you who understand Hindi, the phrase was, we should like jaldi kijiye, jaldabaji mat kijiye. So there is a difference there. Like you try jaldi kijiye, like you can do things fast, but don't do things in haste. So jaldabaji mat kijiye. So that's what we need to do. Like we need to look at the solution, make sure it's really going to work, and then innovate it. Go beyond current or dominant technology, improve, innovate, invent, and make things which really are going to work in our context. And that applies to each and every of the environmental aspect, not only in the toilet, even for solid waste and other stuff. There are lots of things that needs to be done. And as I was saying earlier, as the last bullet of the slide shows you, that we should try to actively engage communities. That's what I was trying to say, that we should always get the stakeholders involved, and that will, because we need to give the ownership. Any infrastructure work that we are trying to do, it's ultimately the local population who is going to use it. So unless and until the local population are on board, that solution may not last very long, because especially when you need the cooperation of the local population to make it a success. So in that case, we need to get this local population on board, get them make sure they are happy with the solution. We have got their input to the solution. If there is something, if we don't agree with something over there, we have convinced them that why we are going the way we are going, and then get their total buy-in, and then they will make it really a success. Otherwise, it's very difficult to make anything successful. So that was the Sandestein sustainable engineering principle. Along the same line, there is another list of principles that is being given, is what is known as principles of green engineering, and they also, again, you will have the same stuff. So I'll just go through this really fast, and just for you to, you can, as you know, this material will be provided to you as a part of PDF, as part of the reading material. All these slides will be provided to you, and I also encourage you to look at some of the books look at the books on life cycle analysis. There are books on sustainable engineering, so get some books. So there are even some books available through certain libraries, like e-books are available. If you start going through Google or Google Scholar, you will find them. So green engineering principle again came up. So usually what happens, there are different committees, different recommendations. So like something like that. Here also we saw Sandestein sustainable engineering principle. Then another committee came up with these principles of green engineering. Green engineering, as in green means you are trying to be environmental friendly. So that's what, and again it's a similar stuff, just rephrased and regrouped in a different way. So principle 1, designer needs to strive to ensure that all material and energy input and output are inherently non-hazardous. We already talked about that. So you try to be as environmentally safe as possible, prevent the waste rather than treating it after cleanup. So rather than, it's better to be proactive rather than let the waste being produced and then we try to clean them up. So it's better to be proactive. Minimum energy consumption and material use. So whenever try to again lower the environmental footprint, and maximize the mass, energy, space and time efficiency. So similar stuff. That's product process systems should be output pull rather than input push. So we should try to look at the through the use of energy and material. Our goal should be more on what the output we are trying to get and how to achieve that output, and for that what input will be needed. Not that we want to make it like too much of input into the system, make it too heavy design, make it over design, and then use lots of energy and materials. And so it should not be too much on the basis of input. Things should be more from the output, what we actually need, and what is the optimum energy and material will be required to achieve that. Then you look at the entropy and complexity of the system in terms of making decision, choice, recycle, reuse, beneficial disposition. Target durability, make it things durable. You don't want to go for immortality, which is not possible in fact. Durable means things last for longer period of time, and that should be a design goal. We should not have one size fits all solution because that's considered a design flaw. That's not going to work. So we should try to avoid that, having a one size fits all solution. Material diversity should be minimized, especially say if you look at that really goes too much against when you try to promote recycling or reuse and those kind of stuff, disassembly and value retention. So we try to for the many times just to make things look a little bit cooler, look a little bit more fancier, we add a lot of material together, and that really becomes a nuisance in terms of the recycling industry. Or so what has been proposed in this particular principle, that material diversity, if needed, we cannot avoid that, but if not, we should try to avoid so much of, say, within one component, if we have just one type of plastic, or rather than having 6 or 7, 8 type of plastic mixed together as a blended plastic, because that becomes a problem in terms of recycling. Then you design a product, process or systems must be integration, like both the available material, energy flow, they should be looked into, and they should integrate with each other. That's always is there. Then we look at what is their performance afterlife, what is in terms of disposal, what after life is over, how it will behave, what will be done. then should be renewable rather than depleting. We should try to go for renewable energy, recycling and all that. So if you look at all these 12 some principles, they are based on very similar to what the Brundtland report said, or what we had the other principles like Hannover Principles or Augsburg Materials Declaration or the Sanderstein Sustainable Engineering Principle. So all these things are essentially saying very similar stuff, and what they are saying is try to make things environmental friendly as much as possible, taking into account that the performance of the product or the system is of course the most important thing. Cost is important, but we should not just look at the cost from like a economical cost. There is a environmental cost, there is a social cost associated with each and every activity. So we should look at those aspects as well. So these engineering principles, so we looked at all those engineering principles over the last 25 some minutes. So this engineering principle, what they do, they establish a framework for designing more sustainable product. So it's how we'll go about that. Again, this slide is too much text on this slide. Again, I kind of gave you to understand, and you can read it, but I will just go over some of these basic takeaway message of these slides. It's basically we need to start looking at we have the products which we have today, how to make this product more sustainable, how to move towards from this inherently unsustainable system to sustainable system. So there is a transition phase right now. We are in a transition phase today. We have a system which we know, which is not going to sustain for a long period of time. We know what would be the solution in terms of a sustainable system. We are discussing like how to move from this point to this point, what we can do to kind of move from one point to another, and that's where we are. That's where industry is right now. So these design principles which have been come up, they will help industry to make this transition. So that's what it's all about. And there will be, when you try to apply this principle, of course there will be some internal conflict. There are always remember, I don't think I have mentioned this to you. One time when I was teaching in Canada, you believe it or not, McDonald's and Walmart, although they are not that environmental, if you go through their profile, they doesn't come out to be very good in terms of their social and other aspects, but we'll not go into that aspect. But they have been trying to incorporate some of the sustainability principles in their organizations. So one of the gentlemen who was a sustainability kind of director or sustainability in charge for this in this Ontario region, he visited and I had him in my class as a guest lecturer in my life cycle analysis class. And he told us that there are many times they come up with a better solution in terms of how the food should be packaged, how the things should be put together, but then the marketing people, they overrule the environmental decision, because what the environmental folks said, that doesn't look very fancy, it doesn't look eye-catching. So that's where things get stuck. So there will be, as I said, there will be some principle, there will be some tension, there will be some inherent contradictions, but we need to move towards it to have a better, like less energy, less water usage, and then we have to come up with a trade-off. We have to have a trade-off between the different objectives, what will work better or which will work not. And we need to start looking at the cost of not only economic cost, but social cost and environmental cost. And in the next module, we will start talking about that cost in some few slides. So what we need to do is we need to incorporate objectives related to sustainability into engineering design, and try to monetize them, put a money value, because as we know, as an engineer or as a industry, we always looks at things from a monetary point of view, how much it is going to cost. So it's not only the immediate cost, but also the long-term cost. And what we mean by immediate cost and long-term cost, we'll cover that in the next module. So I hope that you are enjoying this course so far. It's 7th week, so it's almost there. We have another week left after, I think this is the 4th module of 7th week. So there will be one more module in 7th week, and then we have the last week. So with that, let's close this particular module, and then we will look at the carry forward the discussion in terms of the different cost, economic, social and environmental cost in the next module. Thank you.